Hello, it's Mr. Neil here, and in this video I'm going to review the Software Design and Development Unit from National 5 Computing Science. As you're watching this video, you may wish to pause it at certain points and make notes. If there are any aspects of this video you're not sure of, you may want to undertake further study using resources available to you, including those from your teacher, the SQA website, the BBC Bitesize website, and Scholar from Heriot-Watt University. The Software Design and Development Unit has several key areas: develop methodologies, analysis, design, implementation with data types and structures, implementation of computational constructs, implementation of algorithms, testing and evaluation. You can find the full content of the Software Design and Development Unit within the National 5 Computing Science course specification available on the SQA website. When we think about software development, we go through these steps here. We start with analysis, then progress on to design, implementation, then testing, and lastly evaluation. And in this video I will look at each of these specific steps individually. Whilst the image on screen suggests that we flow from one step to the other, it is possible to go back to a previous step. For example, if I've completed some testing and something doesn't work, I will go back to implementation and review my implementation, fixing the error. If I've evaluated my program and found that my program is not fit for purpose, I may go back to the design stage and retweak my program. But in this video, we'll flow through it from analysis through to evaluation. So firstly, let's look at analysis. Analysis is the first stage of software development, and it's all about analysing the problem that we have been provided with and trying to understand what our software is going to do and how is it going to solve the problem. At National 5 and higher, when undertaking analysis, we think of what information we need to input into the program, what the program is then going to do with that input, that's the processes, and then lastly, what information will the program output to the user. So let's look at this example here. A program is to be developed to create usernames for a class of 20 pupils. The program will ask the teacher to enter the username, surname, and age of each pupil. The age must be entered between 5 and 18, and the program should output a list of usernames for the teacher. So from this analysis, the purpose of our program is to create usernames for a class of 20. In order to create those usernames, the program is required to take in the first name, the surname, and age of each pupil. It will then validate the age to ensure that it is between 5 and 18 before generating the usernames. You'll notice at this stage we're not entirely sure how the usernames will be generated, just that it needs to be done. And lastly, once the usernames have been generated, we must output that information. So when we're thinking about analysis, we're thinking about inputs, processes and outputs. And once we have completed analysis, we can then move on to design. And the design stage is where we will use that analysis to break down our program into steps. And these steps can then be converted into code during implementation. A developer can use a variety of different design techniques, including structure diagrams, flowcharts, and pseudocode. At National 5, you need to be able to read and understand all three design notations. However, you only are expected to be able to write one of these in the exam and in the coursework. Let's start by looking at structure diagrams. Structure diagrams are a visual representation of the steps needed to solve a problem. When we're reading a structure diagram, we always start at the top and work towards the bottom. This structure diagram here depicts a program that is required to calculate the computing grade for a class. That is the big problem that this program is achieving. We then go down to the next level, reading from left to right. So the first step is that we get the number of students in the class. We then move over to the loop each student, and within the loop we want to get the name, then get the mark. Whilst that mark is less than 0, greater than 110, we display an error and then get the mark again. Once this condition is no longer true, we then move on to the next step. calculating the percentage, then on to the next step, rounding the percentage to 2 decimal places, then displaying the name and percent, and finally determining if a merit should be awarded. From the diagram, we can see that the different symbols have different meanings. Circles are loops, hexagons are decisions, rectangles and squares are processes, and these ones with the double bars are predefined functions. If you're not sure of what all these different symbols within a structured diagram mean, then head to the BBC Bitesize website where you will be able to find detailed descriptions of each. Flowcharts are another visual representation of the steps needed to solve a problem, and it shows how the user will flow through the program. So with a flowchart, there is always one starting point and one end point. We start at the top and we flow through a program to the end. And we follow the similar steps to that within the structured diagram. We get the number of students within the class, we have a counter, we get the name, and we then get the mark. We then check to see if the mark is less than 0 or greater than 10. If it is, we display an error, and then we go back round and get the mark. Once this condition is no longer true, we then calculate the percentage, round the percentage to 2 decimal places, display the name and percent. We then check if the percentage is over 80. If it is, we display a merit and then return back. If the percentage is not greater than 80, we progress down. We're then checking to see if the counter is equal to the number of students in the class. If it is not, we loop back round and complete this process again. If the counter is equal to the number of students in the class, we move to the end of the program. Just like in a structured diagram, the different symbols in a flowchart have different meanings. If you're not sure of these meanings, head to the BBC Bitesize website. The next design notation is pseudocode. And pseudocode is a written design notation that is not based on any programming language. It is a cross between English and between code. Generally speaking, one line of pseudocode should equate to one line of program code. Some candidates get worried and concerned about what their pseudocode is. There is no right or wrong way at National 5 to write pseudocode, providing you're given a clear indication of what you want your code to achieve. Looking at the example on screen, we start by getting the number of students. We then repeat for that number of students. We then get the name, followed by the mark. We then have our input validation to ensure that the mark is correct. Once we've calculated the mark, we then calculate the percentage. We then round the percentage to 2 decimal placing, display the name and percentage, output if we have a merit, and then because we're inside a loop, we would repeat background the code again. The advantage of pseudocode over both structured diagrams and flowcharts is that we do not need to remember the different symbols for when we are designing our solution. Another part of design is thinking about how the user will interact with our software. Just like when we're designing websites, we use wireframes to show the layout of our web pages. We can also, when designing programs and software, use a wireframe to show the layout of our user interaction. Once we have designed our program, we would then move on to implementing it using our chosen programming language. As this video is for candidates from all over Scotland, I will not be focusing on one specific programming language, but the main concepts behind all programming languages. When we're storing data in our programs, we can store different kinds of data. We have got integers, which are whole numbers, -43, 72, 134. We can then have real numbers, which store values that have decimal places, 3.1459, -0.012. Real numbers can also store integers. Characters store a single character, so this could be the letter A, it could be the number 3, or it could be the @ symbol on the keyboard. A string stores a group of alphanumerical characters. So this could be a person's name, the registration of your car, your telephone number. A boolean stores two values, true or false. There are different ways that we can store information within our program. And variables are a name place in memory where we store a specific piece of information. So in the example here, I'm storing the value Bruce within the variable name. So at any point later on in my program where I refer to the variable name, I will get the value Bruce. Another data structure that we may use is an array. And an array is a series of memory locations, each which holds a single item of data, but with each location sharing the same name. And in an array, all data must be the same type. So the example we have here is an array called student. And that array holds 5 different values: Matthew, Emma, Oliver, Rachel, and Sam. And within the array, each of these names has a different index value. So at student 0 is Matthew, and student 4 is Sam. And in order to reference a specific student, we utilise the name of the array and the index that we want to refer to. When we are writing our programs, we will probably need to use arithmetic operations. These are addition, subtraction, multiplication, division, and exponent. Addition and subtractions are the same as the symbols that you will use in maths. However, for multiplication, we use an asterisk. And for division, we use a backslash. If you want to find the power or exponent, we use the up arrow, which can be located on the 6 key when pressing shift. So for example, the volume of a cube are the sides cubed, or side times side times side. It is often also necessary to join strings together to make a new string. And this is a process called concatenation. You can see in the example on screen, I'm taking the value of the variable first name and the value within the variable second name and storing them in a new variable called full name. The programs that we write are often required to make decisions, and depending on the result of that decision, it will execute a different instruction. So these are if statements. And the example that you can see on screen, we take the user's age and then determine if they are able to drive or if they are unable to drive. In order to make the comparisons between our variables, we need to use comparison operators. Equal to, greater than, less than, greater than or equal to, less than or equal to, or not equal to. We may also need to make use of logical operators, such as and, or, and not. So with the and operator, both conditions have to be true. So in this case, the username has to be Brian and the password has to be ABC before the contents of that if statement to be executed. For the or statement, either condition must be true before the contents of an if statement is executed. So in this example, the day must be Saturday or the day must be Sunday. The third logical operator, not, is less commonly used because we have a comparison operator that can perform a similar task. In this example here, if not age equals to 18, this means the contents of this if statement will be executed where the age is not 18. Our programs will also include repetition and iteration, or loops. And there are 2 different kinds of loops: fixed loops and conditional loops. A fixed loop is where the loop will always repeat a set number of times. So the example on screen will always repeat 10 times and it will display the message happy birthday 10 times. A conditional loop will keep repeating until a condition is met. So in the example on screen, the while loop, while password not equal to let me in, will keep repeating whilst the password that the user enters is not let me in. Now moving on to predefined functions. Predefined functions are functions that are built into our programming language to perform a specific task. Predefined functions can save us time. We don't have to write lines and lines of code to perform these tasks because somebody else has done it. And because somebody else has written this code, it means that they have tested the code and make sure it works. The round function will take the value of a variable and round it to a set number of decimal places. In this example, the value 3.1459 will be rounded to 2 decimal places. The length function will return the number of characters in a variable. For this example, wordlen will store the value 5 as there are 5 characters within the word apple. The random function will generate a random number between 2 different values. So in this example, the value of bonus can be any number between 1 and 59. Now, depending on the programming language that you use, there may be a number of other predefined functions that you use. For example, you may need to use a predefined function to convert from one data type to another. Moving on now to algorithm specification. Now, you may hear these referred to as standard algorithms, and that's because, generally speaking, no matter the program or the problem, these are always implemented in the same way. The first standard algorithm we're going to look at is input validation. And input validation is used to check that the user's input is acceptable. Now, depending on the programming language that you use, the way that you implement input validation may be slightly different. So let's have a look at one way of implementing input validation. This method is the pre-test conditional loop. In the pre-test conditional loop, we get score from the keyboard. We then check to see if the score is an invalid number. If the score is invalid, we then display an error, and then we get the number again. And we will keep repeating this loop until this condition is false, or the number is greater than or equal to 1 and less than or equal to 100. Another method of implementing input validation is the post-test conditional loop. In this method, we start the loop. We then enter the loop and we receive the score from the keyboard. If that score is invalid, then we display an error. And we keep repeating this process until the score is a valid number. When we're working with arrays, we need to know how to transverse through them. And transversing through an array is the process of accessing each element within the array. When we're transversing through an array, in most program languages, it is necessary to create a variable that will keep track of where we are within the array. This variable is often referred to as a counter. So let's look at how we input information into our array. Firstly, we create our array. In this case, it has been called students. Next, we have a fixed loop. And this fixed loop repeats for the length of the array. So the array has 10 items, so we repeat 10 times. We then get the name from the keyboard, and we then add that name to the students array. And the counter is the value that keeps track of where we are in the array. Once we've inputted our data into an array, we then need to output the data at some point. And we use a similar method. In this case, I've got my array called students. And I'm not entirely sure how many items are in my array. So I'm going to repeat from 0, because arrays always start at index 0, to the length of students. So this will measure my student array and find out how many values are in it, and it will repeat until that value. And the same way that we use the counter to determine the index of the value that we're looking at, we use the counter again when we are outputting information. The last standard algorithm is a running total, and this keeps track of a total inside a loop. So this is an example of a running total from user input. Initially, we set the total to be 0 because we don't have any numbers from the user. We then have a counter that is going to repeat a set number of times, in this case from 0 to 4. We then get the number from the keyboard. Once we have got that number, we add that number to the previous total and store that in the total variable. And as we go through, we will add more numbers to it. It might be that we have the information stored within an array. So we need to access our array and add the values of the array to the total. And you can see that the method for doing this is very similar, but again we have the name of our array and the counter refers to the value within the array that we want to look at. Once we have implemented our programs, it is important that we fully test them. And the purpose of testing is to detect and remove errors within our program. The chances are that when you're creating programs, you would test as you go, because as you run a program, you detect an error, you fix it. It is important that once the program is fully finished, that it is tested to ensure that it gives the correct results. When we're testing our program, we will come across 3 different types of errors. Syntax errors are identified and reported by the translator program when it is translated. And this means that the program, when you hit the run button, will not run and you'll get an error. And that error is likely due to a misspelt command word, a missing bracket, a misplaced comma, the wrong indentation, or breaking the rules of the programming language that you're using. Execution errors are detected during the running of a program. So your program will run, but it will crash unexpectedly. And this could be because you're trying to add a string and an integer together, or you're trying to divide by 0, which is mathematically impossible. Logic errors are the most difficult to detect because the program will run and it will produce an output. However, there has been a mistake within the processing of the program, which means that the output produced is not the output that you expect. So in order to fully test your program, and in particular identify if there are logic errors, we need to use a variety of different test data. We don't just pick test data at random, we think about the test data methodically to ensure that our program can handle as many scenarios as possible. So there are 3 different types of test data. Normal test data is data that we expect our program to work with. Extreme test data is data at the boundaries of what our program should expect. And exceptional test data is data that our program does not expect, but we should be able to handle it. So for example, if our program is requiring a percentage, therefore the number must be between 0 and 100, a normal piece of test data would be the numbers 8, 34 and 91. The extreme pieces of test data would be 0 and 100, as these are at the boundaries of what is acceptable. An exceptional test data would be minus 23 because it's below 0, 103 because it's above 100, and the word 20 because it is not a percentage. Once you've tested your program, we then go on to evaluate it. And we evaluate it in a number of terms. One of these terms is its fitness for purpose. And this means we're assessing whether our program does everything that it was identified that it should do. So we look at the finished program, we look at our initial analysis and determine if it does everything that it should do. We can also evaluate our program and its efficient use of code. And when we're talking about efficient use of code, we're answering 3 questions. The first question is, does the program make use of repetitions where possible to reduce the amount of code? For example, if we wanted to print out the 2 times table, we could have multiple different print statements. Or we could make use of a fixed loop and a counter that would complete the same thing. The second question is, does the program make use of arrays instead of declaring many variables? So if I wanted my program to store 5 different numbers, yes, I could use 5 different variables, or I could create an array and use a fixed loop to enter numbers into that array. The last question is, does the program make use of selection statements that will only make comparisons until a solution is reached? Let's have a look at an example to see what we mean by that. Here we have an inefficient solution that's trying to determine which team has won, Team A or Team B. So let's assume that Team A has 4 points and Team B has 3 points. So 4 equals 3, that's not true, so we go into the next statement. 4 greater than 3 is true, so Team A has won. But then we go and check and see if 4 is less than 3, which it is not. So the fact that we are checking to see if this is true, when we know this is true, means that we're being inefficient, because at this point here, we have reached our solution. So in order to make this solution more efficient, we can use an if-else statement. So if 4 is equal to 3, then draw, but it's not. Else if 4 greater than 3, then team A has won. So we do not check the rest of the if statement. When we're talking about robustness, we mean our programs to cope with unexpected inputs or mishaps without crashing. For the purposes of National 5, this is referring to the fact if our program includes input validation. Lastly, when we're evaluating a program, we can think about its readability. A readable program is a program that is easily understood by another programmer. Can somebody else pick up your code and understand it? And in order to make your code more understandable, we can implement the 4 strategies shown on screen. We can add internal commentary, and this is commentary that explains what the code is doing, but it's not executed. It is merely there as a description. We can make sure that our variable and array names are meaningful and indicate what content is in them. For example, a variable name of first name is a lot more meaningful than the variable fn. We can use indentation and white space to show where different constructs start and end. In this video, I have reviewed the National 5 Computing Science Software Design and Development Unit. We have looked at analysis, design, implementation, testing and evaluation. Further information from this unit can be found on the SQA website, the BBC Bitesize website and within the Scholar website from Heriot Watt.